Hi, I'm Dr. Jackie White from St. Leo University, and today we will be discussing measures of center. What we're going to do first is review the definition of what we're going to be looking for. Then once we know what those definitions are, then we can move on and we can explore each of those different ideas with an example. So to begin with some of our different definitions, well, what is measure of center? We said we're going to be looking at that. Well, measure of center is a value at the center or middle of a data set. Makes sense, right? Center. And so there are several different ways to represent the middle of the data set. One way is the arithmetic mean of a set of values. And what that is it's the measure of center that's found by adding the values and dividing by the total number of values. Now, hopefully that sounds kind of familiar to you because an arithmetic mean is just an average. For instance, if you've taken several quizzes, then if you take the average of your quizzes, what you found is actually the mean of your quiz scores. Now, some that are not quite as common in daily life but are very common in the study of statistics is the median. And the median of a data set is the measure of center that is the middle value when the original data values are arranged in order of increasing or decreasing magnitude. So what that means is if you actually put all your data in order from either smallest to largest or largest to smallest, it doesn't matter which order, then you'd look at that very middle data point. In other words, drop off numbers from the top and the bottom of your set till you're left with that one value in the middle if you have if you have an odd number of data points. If instead the number of data points is even, then when you're dropping off the top and bottom numbers, you're going to be left with two values that share the middle. So if you have two values left in the middle, then to find the median, you just take the average of those, add those together and divide by 2 to get the median of your data set. The mode, on the other hand, the mode of a data set is often denoted by capital M, and what that is just the value that occurs the most frequently. Now, sometimes you have just one value that occurs more than any others, so that's obviously the mode. Sometimes there are no data points repeated, in which case then you'd say there's no mode. Sometimes you'll have two different data points that are repeated an equal number of times, that are the most times that it's repeated. Well, in that case, your set is called bimodal. Bimodal simply means two modes in your data set. If you've got more than that, usually if you've got 3 or 4 data points that are all repeated the same number of times, the data set would be called multimodal, but typically you would just not list a mode if it's more than 2. So if there's no mode at all, you just write no mode. If you find one value that's repeated more than any other, that's your single mode. If there's two values repeated an equal number of times, then it's called bimodal and you'd list both of them. If there's more than that, then you wouldn't list a mode once again. It would be called multimodal and you wouldn't evaluate or you wouldn't elaborate upon what the modes were in that case. Then we have something called the mid-range. Well, the range is the difference between the highest and lowest values, so the mid-range is the middle. So the mid-range is the measure of center that is the value midway between the highest and lowest values in the original data set. So the way you come up with that is that you add the two end values together, and once you've added the two end values together, then what you'll do is take that result and divide it by 2. So to find the mid-range, add your two end values together, then divide by 2. Now what I'd like to do is look at an example. Here, it's easy to say the definitions, but that's not necessarily real helpful. If we look at it within an example, then you can begin to see how you would calculate each one of those with a particular data set. So first I'm going to read the scenario to you. Once we've done that, then we can look at the data set itself and investigate the different mean, median, mode, etc. So what we have is, when investigating times required for drive-through service, the following results in seconds were obtained. Find the mean, median, mode, and mid-range for each of the two samples. Then compare the two sets of data. So we'll look at the data set for McDonald's first, and then you don't see it yet, but we're going to see the data set for Jack in the Box as well. So here you can see the data sets. We've got McDonald's and also Jack in the Box. 2 data sets means I'm going to do the first one here, or we'll do it together and you can see. Then what we'll do is give you some time to go ahead and calculate the same values for the second data set. So I'm going to start with McDonald's and work through these data points. These are the times at the drive-through. Then once I do that, you'll be repeating, so pay attention, you'll be repeating those same steps to do it with Jack in the Box in just a minute. So what I want to do is, looking at McDonald's then, there are 4 different values that I want to calculate that are the ones we talked about. I want to calculate the mean, the mode, the median, and the mid-range. So we said that the mean is just the average. So what that means is I want to add up all of these data points that I have and then divide by 12. So if I add up all my data points, I'll have 2,236. That's what I want to divide by the 12 because that's how many data points there are. So I have 12 data points, so when I divide that out, I have that this will be approximately 186.3 seconds. That means that's the average amount of time that you would wait in a McDonald's drive-thru. So that's one way to look at the average or center. Then mode, we'd say, well, which data point is repeated the most often? And if you look at these data points, though, you'll see none of them are repeated. They're all different values. So either none or no mode, or somehow you'd express that there is no value repeated more than the others. Now here's the convenient part for me. With median, these data points are no longer in the same order they were on the other page because I went ahead and put them in order from smallest to largest. The reason I did that is because that's going to help me identify the median. Because remember, the median is that center data point value. So, for instance, there's 12 data points. So I could look at the bottom 6 and then look at the top 6 and see where's that break. And the break is between 176 and 192. So drop off the bottom 5, drop off the top 5, and I'm left with these 2 data points. So what that means then to find the median is that I'd have to add 176 plus 192 because we have an even number of data points. It means I have to average the 2 middle ones, add them together and divide by 2. When I do that, I see that I have 184 seconds for the median. Finally, for the mid-range now, mid-range I'm going to look at the lowest value. Once again, once it's in order, mid-range is much easier to do as well because I can quickly see that 92 is the smallest value, 287 is the largest value. So what I want to do then is add 92 plus 287, then divide that by 2. I'm averaging the endpoints to see that I get 189.5 as my values for McDonald's. So the mean is the average of all of the values. The mode is the one that's repeated the most often. The median is, because it's an even number, it's the average of the middle 2 values. Finally, the mid-range is the smallest and largest values averaged together. Now, I repeated what this says here. The reason I repeated that is because now it's your turn. So we're going to look at the Jack in the Box data. What you have is the same data points. Now notice these are not as conveniently put in order, are they? You're going to have to do that. So here are all the data points. You'll want to put them in order, and you'll want to find the mean to get the average. You'll also want to find, again, the median, the mode, and the mid-range, those 4 values. But you know what? I had a little advantage here. Why don't we go ahead and, for your first time, give you a little shortcut as well. Now you can see, now you do have those data points in order. So remember that you would want that to be your first step, to put the data points in order. I chose from smallest to largest. Then you'll go through and calculate each one of these. So you're going to pause the video right now to do that. When you're ready, just start back up again, and you can compare your numbers to mine, and we'll see how we did. Okay, well, here are my results. Let's hope they match up. That decimal's a little small there. You should have, for your mean, gotten 262.5. If you didn't, and you trust me, then you should try it again. For the mode, that one's an easy one to check right now. You can see 109 is duplicate there, so that is the only one that's repeated more than once. Going back to the mean, if you didn't get this number, just remember you should be adding up all the data points and then dividing by the total number of data points. So go back and check that. Otherwise, then the median here, again, because of the number of data points, you'd want to average the 2 middle ones together. So if you go between 255 and 270, taking the average of those, you should get 262.5. And then finally, for the mid-range, adding the 74 and the 481, when you divide that by 2 to average them, you should come up with 277.5. Now what I would like to do is look at the results that we had for McDonald's and the results for Jack in the Box together to say, well, so we have all these results. Do they really tell us anything? Well, for McDonald's, we can see that each, the mean, the median, the mid-range, and in this case, no mode, they're slightly different, but they're pretty similar. They go from 184 to almost 190, so they're pretty, close to each other, although there are slight differences. Same thing with Jack in the Box. We've got, well, the mode of 109. We can see that's significantly different from the others, so that would not be a good choice to show as the center as far as the middle point of your data goes here. But if we look at mean, median, and mid-range, we're still ranging between 262.5 to about 278. So there's some variation there, but what we can clearly see is that McDonald's numbers are much smaller than Jack in the Box numbers, meaning if you're in a hurry, go through McDonald's drive-thru because the average weight there or the likely center value for your wait in line is going to be shorter, which is actually a quicker wait than at the Jack in the Box where you'll be waiting a bit longer. So looking at that then, what we can also do, that's just the mean, median, mode, mid-range of a specific data set. What we would also like to do sometimes is find the mean of a frequency distribution. Remember, that's where we've already taken our data and organized it into our frequency distribution, rather than looking at every individual data point. So it's the same idea that you used to find a weighted mean before, because the class midpoints, if you look at the first column in your frequency distribution, that the class midpoints of your classes, that could represent, that's similar to the values, and then your second column in your frequency distribution is the frequencies. That would be similar to representing the weights instead of the frequencies. So it's kind of the same concept. But what I'm going to be doing is I'm going to be looking at the idea of how to calculate the mean for a frequency distribution. And what I'm going to do is actually use the TI-83 as a tool when I do this. So I'm going to go over an example, and then I've entered the data into the calculator, and I'll show you where it is and what it looks like. And then we'll go through the calculation to find the mean of a frequency distribution using the TI-83 calculator. So in this case, the example I'm using is that the given frequency distribution describes the speeds of drivers ticketed by the town of Poughkeepsie Police. These drivers were traveling through a 30-mile-an-hour speed zone on Creek Road. How does the mean compare to the posted speed limit of 30? So I'm going to have to show you the data that we have in the frequency distribution. Then what we're looking at is those speeds that were recorded, how's that compare to the speed that they were supposed to be going, which was 30. So we always want to answer the original question. So we're going to find that mean and then compare it to 30 miles an hour. See, here were the speeds. They broke them into zones of 42 to 45. There were 25 people going at that speed. Then 46 to 49, there were 14 people in that speed, etc. 50 to 53 had 7 people. 54 to 57 had 3 people. And finally, 58 to 61 had 1 person. So if we go to the calculator, what I'm going to do is go into Stat. That's the second row, third column. And then I'm in Edit, it's highlighted, so I'll select Enter. Now here I've already entered list 1, and what I've done is gone the midway of the first class. The first class went from 42 to 45 miles per hour, so halfway in between that, the midpoint is 43.5. And I did that in list 1 for each of the classes. So I have 43.5, 47.5, 51.5, 55.5, and 59.5. And from there, then in list 2, I entered my frequency. So that's just straight down the list, 25, 14, 7, 3, and 1. So I've got my data entered. What I can do now is go to Stat, Calculate. Now here's something that we could have done with our prior data sets. If I just select one variable, statistics, under Calculate, if I were to hit Enter now, what this does is this actually will give me all the same information we're going to see in a minute, but it would give it to me just on my first list. So with the prior example, had I wanted to, I could have entered it into list 1 and just done one variable, statistics, by itself, instead of hand calculating the mean, median, mode, etc. However, because I've got list 1 and list 2, I need to find the list 1 keys. I hit second 1 because that's where list 1 is at, then the comma above the 7, then second list 2 to say I want the one variable statistics with both of these lists to include the frequency in my calculations. When I do that, I can see then that I have 46.78 as my value, or you could round that to 46.8 possibly. But what I can see then is the mean of that original data set is 46.78. Now remember, the original speed was 30, and here we're saying that just the average seems to be 46.8 roughly. So looking at it, 46.8 is a lot higher than 30, so it looks like that's probably a problem zone with quite a few people speeding there. I mean, that's one way we could use then that measure of center to see if there's a problem or not as far as speeds are concerned. So we've learned how to find several measures of center from a set of data. We saw mean, median, mode, and mid-range. You want to review these techniques, and also while you're at it, you should review table 210 so that you can see the advantages and disadvantages of each, so you know which one to choose in particular situations. But that concludes our look at measures of center.